Okay, let's go ahead and get started. It is 7:30, and today's skill is pretty much everything we've learned, but with a less than sign, well, that's less than or equal to, a greater than sign, or greater than or equal. So what does that mean and how is it different? And so just reading from the top, a linear inequality describes a region of a coordinate plane called a half plane, and all points in the region are solutions of the linear inequality. And so the boundary line of the region is the graph of the related equation. So for those of you that like step-by-steps, first you solve for y. Remember, when you're working with inequalities, anytime you multiply or divide by a negative number, the inequality flips over, okay? And then you're going to draw what's called a boundary line. The boundary line cuts it into two half planes. You use a solid line for anything with an equal sign and a dashed line for anything that doesn't have an equal sign. Okay. Now, step 3, I think there's an easier way, but this is what they're suggesting. You pick a point and plug it in, and you decide what area needs to be shaded. And then you shade the region above the line. This step is what I would recommend. So if it's y is bigger or y is bigger than or equal to, you shade above. If it's less than or equal to, you shade below. And you can check your answer. And so let's start with the first couple. For each one, tell whether the graph is a solid or dotted line. Well, notice that has an equal sign, so I would say solid. This does not have an equal sign, so that's going to be dashed. And finally, this one has an equal sign, so it's solid. Next, determine whether you're going to shade above or below the line. Well, less than is below, right? So I'd say below. Greater than is above. And then greater than is, once again, above. And I should say greater than or equal to. All right. That's like a quick summary of linear inequalities. Probably have seen this before. So what we're going to do, give me just 1 second. So notice I have two equations. Well, I should call them inequalities because they're not equations because they're shading. And notice on this first line, we shaded below. And on this line, we shaded above. And so I don't know if you're able to see it, but over here is where the shading crosses. And so this would be what we call a solution to the system. So anything over here, and I'll highlight it so you can see it better. Anything over here is what we call a solution to the system. Okay. So how do we know if a point is a solution to the inequality? Well, it's a solution if it is in this area. Okay. So which of the following points is a solution to the system? 2, 7. Let's see, is 2, 7 a solution? 2, 7. 2, 7 is a solution to this inequality because it's above, but it is not a solution to this inequality, which is below. So in order for it to be a solution, it must be in this area called the feasible region. And so I would say, no, that is not a solution. -1, -5. Again, is a solution to this one, but not this one. So I would say no. 2, 1. Again, not a solution. It's not in this area. And then -5, -2. Just barely. So I would say, yes, this one is a solution. So in order to be a solution, it's in the area of the shading that crosses. So like if you pick this area, it's only a solution of 1. If you pick this area, or I should say this area, it's only a solution of this one. But if you want it to be a solution to the system, it must be in this area called the feasible region. And so one question they may ask you is this point a solution? Well, how do you know? You plug in. So, and I'm not quite sure why they have a table there, but let's see, if I plug 1 in for y, and then I plug x 2, I get -2 plus 4 is 2. Is 1 less than 2? Less than, I brought down my less than sign. So I would say yes, 1 is less than 2. And then, so I would say 2, 1 is a solution to this inequality. But is it a solution to the system? That's what's important. Let's plug 1 in for y. And let's plug 2 in for x. 2 plus 1, 3. Is 1 less than or equal to 3? Yes. So because it worked for both, I would say the ordered pair is a solution. To the system. Now, if I were to plug it in and it worked here but did not work there, then my answer would be no. In order for it to be a solution, it must work for both. So now that we got all that out of the way, the skill today is, can you take two inequalities, graph them, and show where the shading crosses? And where the shading crosses is called your feasible region. How you want to represent that is up to you. You can use colors. Probably the best way to do it with pencil is, notice like when they're graphing here, they kind of make the lines this way. And then when they're doing here, they make the lines this way. And then you can clearly see where the feasible region is because I have lines going both ways. That's usually the easiest way with the pencil, but you could also use highlighter, marker. You could shade darker in that area. There's multiple ways to represent this. So if I'm able to go, oh, you mean over there, then we're good, okay? The keys to this, why kids miss this, is they forget the difference between a dashed and a solid line, or they never learn how to graph inequalities. Let's get started. So this is kind of review of what I said. So here's another way to show it. See how it's darker? And so I would say because 2, 1 is in the area that's darker, it is a solution. Whereas over here, it's not in the overlapping area, so I would say it's not a solution. So let's start with what probably is a simpler one. Forgot I can't zoom in on this one. So let's start with y is less than 2x plus 4. It's already solved for y. You graph it just like you're used to. You start at 4. 4 is the y-intercept. And you go up 2 to the right 1. So you're going to go up 2 to the right 1 for the slope of 2. Because we can't really do that, I'm going to go down 2 over 1 to the left 1, which is still up 2 over 1, just backwards. And then down 2 over 1. Now I have to pay attention. These are both going to be dashed lines. So all I did was graph so far, y is less than 2x plus 4. And then less than means shade below. So I'm going to shade below. And I'm terrible at shading, so please forgive me. And please remember that this goes forever. We just don't represent that. So like technically this goes forever and forever and forever. We don't have time to graph forever. And then let's do the other one, 2x plus 1. Where did I say that from? I mean x minus 1. So I start at minus 1. And the slope is 1 over 1. So I go up 1 over 1. And also this way. And this is kind of a poor example because it's hard to see. It's kind of hard to see where the feasible region is going to be. I almost have to extend the graph a little bit. And so let's see. Greater than would be above the pink, so I'm going to shade above. And above is going to be everything above this line. And so I know it's kind of hard to see with my shading. I'm not an artist, never have been. But see where the green and the pink overlap is this area. And so if you're not able to see it very well, it may help to just like color that side in. And I don't think that looks very pretty. But this area right here is where the shading overlaps. And then even more so, if you're still not sure the teacher could see it, you can label this the feasible region. Okay. I'll try to be a little prettier with my shading next time. Let's go ahead and do D. D, y is bigger than 2. So I go to 2. Y without the x is a horizontal line. It's going to be dashed. So I'm going to go dashed at y is greater than 2. And maybe it'll help to not shade as dark this time. So I'm going to try to shade a little lighter. Now, why did I shade above? Because it's greater than, and in our notes we said greater than, you shade above. And then y is less than or equal to x plus 1. I'll identify this as my green one. So I start at 1. 1 because that's the y-intercept. Slope is 1 over 1. So I go up 1 over 1. This time, because it has an equal sign, it's a solid line. And then less than means shade below. So I'm going to shade this area. And so I shaded above, but below. And so this area right here is going to be what's called the feasible region. There's basically, it's kind of like taking a pizza and cutting it into two ways. You're going to end up with 4 slices. And so you have to identify which of the slices is the solution. And so like I have a slice here, then I have this slice. So this would be like someone taking a pizza, cutting it like directly horizontally, and then at a diagonal. Some of the pieces are larger than others. So I have this piece, this piece, this piece, and this piece, 4 pieces. And you have to identify which of the 4 is the feasible region. It's only going to be one of the 4, and it's where the shading overlaps. All right. Any questions so far? So the 3 people I see are shaking their head no. I'm going to skip around a little bit. We'll do E first. Notice E is a little different. And the reason why it's a little different is because your second inequality is not isolated for Y. So we're going to have to isolate that for Y. And so if we're isolating that for Y, I'll do the work real fast. You treat this just like it's an equal sign, except if you divide or multiply by a negative number, then the inequality flips over. Okay, so if I'm solving this, I want Y by itself, so I get rid of the 8x first by minus 8x on both sides. I get 4y is less than or equal to negative 8x plus 12. And then I divide by 4. And I get y is less than or equal to negative 2x plus 3. Now here's what I was saying, like say that was a negative 4y, and then you divided everything by negative 4, then this would change from less than or equal to a greater than or equal to. Okay, so anytime you divide by a negative number, this will change directions. We divided by a positive number, so we're fine. All right, so let's go ahead and graph this one, negative 2x plus 3. I start at 3. And it's going to have a negative slope. And the negative slope is down 2 over 1. And it has an equal sign, less than or equal to, so it's going to be a solid line. And I'm going to shade underneath. I wonder if I have. Let me use pencil this time. So pencil. I think that might make it easier to see. Okay, so this was the green one. Now, let's do this one. This one says you start at -2, and the slope is 1, go up 1, to the right 2. And notice it does not have the equal sign, so that's a dashed line. Greater than means shade above. So above would be this way. And so you can see when you use pencil, and I've seen kids, they do way better job shading than I do. It's not my strong suit, but you can see, you can clearly see looking at this where the feasible region is. But again, if you're not sure the teacher could see it, you can label it. The pencil's too large for the camera. You can label it feasible region. Region means area, feasible means this, anything around here is a solution. So what that means is this point is a solution because it's in that area. This point's a solution. That point's a solution. This point's a solution. Anything over here, not a solution, not a solution, not a solution. So what that means is the reason why we have shading is that there are infinite amount of solutions that you could pick, especially since this goes forever. Okay. So when we did systems of equations, there was usually just one solution. Since we're doing systems of inequalities, there are too many solutions to list. They're infinite. And so instead of saying infinite, we're showing that graphically by showing the graph and saying anything over here. Okay, this goes forever, that goes forever, 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 anything in this area. Okay. So as a summary, you can graph a system of linear inequalities by just combining the graphs of the inequalities. So here's an example. They took 2x plus 3. Notice it's a solid line, less than the shaded below. Here, they took -x minus 6. So they started at -6, went down 1 over 1. They made the line dashed because of the greater than sign. And then the greater than means shade above. And so these are two separate inequalities. But as soon as you combine them into a system, you can just plot both together, which is what they did. And so the area that's darker is what's called the feasible region. So if you're struggling, you could graph one on one, graph one on another, and then combine them together. Okay. Now, I don't remember if, I know the graphing calculator doesn't, I should have checked this before, but I don't remember if you can do, you can. So let's go and check our work for the last one we just did. Y is greater than 1 divided by 2, x minus 2. And then the other one, and then how did I get the greater than sign? On my keyboard, by the question mark, I have a greater than sign. And then the other one was 8x plus 4y. And I'm going to do less than, and then type equal sign on my keyboard. And it's smart enough to do that. That's 8x plus 4y is less than 12. And notice, this feasible region's over here, and it goes forever. It's infinite. I mean, we're down to what, 1 million now? Like, So I really took the numbers here. I don't like scientific notation, but you can see like the solution, there's infinite amount of solutions. And then this is exactly the same thing we just had. That is the same thing we had. So you could also use Desmos to check your work. All right, so we have 5 minutes. I just want to just make sure you know that you need to sign up for that test. There is a practice out there. There is a quiz out there. You need to sign up for the unit test. I will say this is not on the test, so you do not have to worry about this for the test. And you do have access to Desmos. So when you go in, there's a tool button. You just click the tool button in Desmos, and it brings up the calculator. If you need scratch paper, please ask the person for scratch paper. You are allowed scratch paper, but you are not required to turn in any work. So just kind of keep that in mind. Substitution and elimination are great methods, but if you have Desmos, feel free to use it. Like it's a guarantee answer. So other than that, I'm signing off of here, and I'm going to sign into office hours. Let me know if you have any questions, and we could talk individually, or if you just want to stop in and say hi, that's fine too. So hope you all have a nice day. Bye-bye.